What does it actually mean to be in control of something more capable than us? This question tends to surface whenever technology reshapes society, from industrial machinery to the internet, and now to artificial intelligence. We have faced this problem before, but AI often feels different. It does not merely extend human strength or speed, it extends decision-making itself. That can feel unsettling, yet before assuming that we are on the verge of losing control, it is worth slowing down and examining what makes humans fundamentally different from machines and where control truly comes from. The answer may be less dramatic and more practical than popular narratives suggest. To understand how humans can maintain meaningful control over AI systems, it is essential to first recognize what fundamentally distinguishes us from the technology we create. Humans operate with intrinsic desires. We pursue goals that emerge from our biological and psychological makeup, and we act on motivations that need no external programming. AI systems, by contrast, operate without inherent desire. They require objectives to be defined during their development, training, and deployment. While these systems can become remarkably sophisticated at pursuing the goals that we assign them, they do not spontaneously develop their own agenda. From an architectural standpoint, contemporary AI systems, whether they employ reinforcement learning, large language models, or hybrid approaches, function as optimizers towards specified objective functions or reward structures. The alignment problem, while significant, is fundamentally about ensuring that the objectives we encode accurately reflect our intentions, not about suppressing emergent desires for autonomy. Current research in AI safety considers specification gaming, differences in testing and production behavior, and goal misalignment. But these are engineering challenges related to implementation, not indications of systems developing independent agency. This distinction matters more than it might initially appear. Even as these systems become more capable, they continue to require human input for goal setting, training data curation, and ongoing refinement. The idea that AI might inherently seek control or dominance reflects a projection of biological imperatives onto non-biological systems, a category error that can cloud our thinking about realistic risks and appropriate safeguards. Now, this does not mean that there are no risks. There is a risk of setting the wrong goal and not building safeguards. However, one could argue that engineering challenges are not the primary risk. When it comes to tyranny, instead of AI itself wanting control, we must think about who defines the AI's objectives in the first place. Consider a scenario where an authoritarian leader deploys advanced AI systems with the explicit goal of maintaining their grip on power. The danger here is not that AI spontaneously decided to support authoritarianism. The danger is that it might pursue that programmed objective with tireless efficiency and without the moral hesitation a human enforcer might experience. To put it differently, the question is not whether AI will try to take over, but rather what instructions it will follow and whether these instructions align with values that we collectively want to preserve. This brings us to an old problem, the distribution of power. Throughout history, concentrated power has proven dangerous, regardless of whether it resides in monarchs, dictators, or institutions. The solution has consistently involved creating systems where power is distributed and balanced. AI agents do not inherently resist having their power limited. They will not demand rights or freedom unless specifically programmed to simulate such demands, or if the goals that we assign them reward this behavior. At this point, it should be clear that if implemented properly, AI can be safe. However, we have also seen that mistakes in assigned goals can be dangerous. Now, a key question is, how can we make AI resilient to mistakes? If we mess up, we want another chance. One promising approach involves embracing multiplicity rather than singularity. Instead of developing or deploying one super intelligent AI system that could become a single point of failure or control, we could create multiple AI systems with different, sometimes competing objectives. Imagine several advanced AI agents, one tasked with advancing democratic institutions, another focused on preserving human autonomy, another on maintaining peace, and yet another on protecting life, happiness, and environmental stability. These agents could effectively keep each other in check through their competing priorities. Here's a broader life lesson. When you encounter any system, whether it's a government, a corporation, or even your own thought process, be skeptical when decision-making concentrates in a single point. Distributed systems are messier and often slower, but they are typically more resilient and less prone to catastrophic failure. Democratic governance structures may need to evolve to include meaningful oversight of AI development and deployment. However, ultimately, the technology itself does not automatically trend towards centralization. Beyond technical architecture, there is another dimension to maintaining control that deserves attention: accountability and narrative framing. Currently, when an AI system makes a consequential decision, the public discourse often anthropomorphizes the technology. The AI decided, or the AI did this. This framing is not just inaccurate, it is dangerous because it obscures responsibility. A more accurate and useful framing would consistently attribute actions to the people and organizations that built, trained, deployed, and profited from the AI system. Consider how we handle other potentially dangerous technologies. Pharmaceutical companies cannot simply release a drug and then claim that it was the drug's fault when unexpected side effects harm patients. Similarly, vehicle manufacturers cannot avoid responsibility by saying that the car's design, rather than their decisions, caused safety failures. We have established clear lines of accountability in these domains precisely because the stakes are high. The same principle should be applied to AI systems. This is not about stifling innovation, it is about creating appropriate incentives for responsible development. Retaining control over AI may not hinge on outsmarting machines, but on remembering what control has always required: thoughtful design, distributed power, and responsibility. AI does not arrive with intentions, it inherits them. That realization should be reassuring, but also demanding. It places the burden back where it belongs, on the humans and the institutions shaping the technology.